Okay, this is very disorienting. Can you hear me? Echoing, huh? Let's try this. How's that? Is that better? Okay. All right. I think that's better. I think that should be working. There's this silly delay in this, so it'll take a little while for me to like catch up to what you all are saying. Okay, great. Hello. How's it going? I am known as Whopping Potchard on Discord, and this is my lair. Welcome. Today, I'm going to be trying to do some anodizing of titanium backers, which is very exciting. Um, and let me just sort of like walk you around the lair right now. I'm going to try swapping over to my fancy camera. Okay. Yes. Cool. Hello. This is my bench. I cleaned it up for all of you very nicely. Thank you for giving me the excuse. Some unused and non-functioning 3D printers over on this side of the bench. Um, this is hopefully the star of the attraction today. This is the Autodizer um, that is going to be doing the controlled CNC anodizing. Um, and or at least this is the sort of like functional part of it. Up here is my general purpose tester, the rainbow tester, which is running Clipper and an SKR 1.4 that's going to be controlling all of it through this little cable thing here. I can attach other test rigs to that. And then this is the actual sort of like business end of it, where the anodizing actually is going to happen. So here we've got our first tank here, which is going to have our etchant solution in there. Right now it's got a heater and a thermometer. Then it's going, well, this sort of goes in here like this. So we'll put our etchant in here. Oh, that's a little full. It's probably okay. That's fine. That's fine. All right. And then this one, I'm going to have to clean out because it's kind of dirty. We're going to put our distilled water to dunk in there. And then the actual anodizing is going to happen in this tank here. So we've got some stainless steel mesh back in there. And that is attached to our negative electrode. And then our backer is attached up here to this plastic rod. It's got some titanium wire. And then it's going to the positive electrode, which is going to go back to this machine here. So the anodizing needs to have DC current because we're going to move electrons somewhere off of the material in question. And so to do that, we have a variac here, or an auto transformer. And so this is a old thing that I picked up from the free table at the lab that was previously used in probably a neurobiology lab. I'm not totally sure. And I've hooked it up with a little end stop and a motor to control it. And then, so that is generating an AC, a variable voltage AC waveform, which is going to go into a rectifier, which is down in there. That rectifier is going to turn it into DC, and then it's going to be smoothed by this big old capacitor. And then that's going to be ready for us to use. And there's some other junk in there that's going to like show the voltage and the current and things through this little screen here. Um, that's our etching bath temperature controller. And then this is the big old emergency stop button. So if something really bad happens, then I will slap that, and that will cut the AC power in from the Variac. And then this green button, is what I push to actually connect the DC electrode leads. And this is a momentary button. So it's sort of like a dead man switch. I have to be holding this actively for DC power to be flowing through the leads, which is important because if I like suddenly get shocked and become comatose or something, I will hopefully no longer be pressing that button. I once did have a mighty beard. It is true. However, these days I do not. Okay, and this is going to get real annoying. So in the future, this is just probably going to be a switch after I confirm that I'm not going to kill myself doing all this other stuff. Okay, so let's go over kind of what I want to do tonight. All right, so this is indeed the first time I've ever actually run this. So there's a little bit of setup stuff. I apologize, I didn't quite get my shit together fast enough to do everything ahead of time like I wanted to. But we've got a test backer in there already. And so what I'm going to do is I'm going to take that out. I'm going to get rid of all the oils and stuff using some Simple Green degreaser. I'll probably have to do that outside of my tent. And I'm also going to have to wash out this big pipe and put some distilled water in it. And then I'm going to have to fill up all my tubes. So I'll turn on the sort of like overhead camera while I'm doing all that. And feel free to chat and stuff, and I will hopefully get going here pretty soon. And then we can actually run through the code and stuff that's running all of this. So here we go. Here's the overhead camera. Great. I'm going to go get things ready. Oh, this is a cool part. This is one of my favorite things, actually. So I printed these little cleats that these tubes sit in so I can hang them securely and take them off to clean and stuff. Right, one is all set. And what else do I got to do? Oh, this thing is probably, yeah, there's some shit in there, so I'm going to have to turn the power off here. Nope. So I made this thing so that it tilts, so I can do sort of like angled gradients on the backers. Just because I think that'll like look kind of cool. I think Derpamis is going to get the first angled gradient backer. So this is really all in service of their totally awesome looking backers. And hopefully yours in the future as well. Yeah, so it is not actually acid in the etchant. It is two fairly innocuous chemicals: sodium fluoride, which is in mouthwash and toothpaste, and ammonium persulfate. Where's the friggin' camera out here? And so this is cool because it's like much less dangerous than the high acid etchants that are typically used for titanium. Um, this is available commercially under the brand um, multi-etch. And there are some forum posts where you can get the formula on Reddit that I tracked down. And apparently this stuff was patented some time ago, but is no longer under patent. Oh look, first blood. It didn't take long. Oh, there's another thing that I forgot to mention. So I am going to be selling these in a little web store, which will one day soon hopefully be where I sell the stuff that I actually got into 3D printing to do, which is make inexpensive biology lab equipment. But for now, it's just going to be like Gucci boron stuff. So um, that is all ready to go, and is a thank you for hanging out with me tonight. I'm going to give you the password to the currently protected site. So let me drop it into chat. I don't even know how to do chat. How do I do chat? Here we go. Okay. So we go to www.lightweightlabware.com and you enter my screen name on Discord, you can go in and check out my wares and purchase them if you would like. There's also a discount code that fans of DFH's channel should be able to guess. I'm not going to state it publicly, but I think some of you could probably guess it. So right now it's just going to have like anodized backers and keychains and titanium screws in there. But we'll see what else goes on there in the future. Bump. Let's see. So we're all clean. Let's see, go through our checklist. We're clean. We've got warm water. So now I'm going to go. Now I'm going to pour in our etchant here into the heated bath, and we're going to wait for that to come up to temperature. So I'm actually going to start using my gloves. At this point, even though it's not super toxic, like, smoke them if you got them, right? All right, that is our etchant. It is in there, it's heating up. I will check the temperature with my fancy little infrared temperature thingy thing. And then I'm going to pour some deionized distilled water into the cleaning bucket. Water bath to heat the etchant. Yes, exactly. Because this etchant, so I don't know exactly how it works. I was trying to look that up today, and I wasn't able to find it fast enough. But my impression is that it's actually producing hydrofluoric acid locally on the surface of the metal um, via the APS and the sodium fluoride. And so you do end up having hydrofluoric acid in there, but only ever immediately consumed by the material. Um, and apparently we'll also do that in metal or glass vessels. So you don't want to keep this particular etchant in glass or metal. So to do it safely, you need to have some sort of like double boiler system where you've got like a plastic container inside another metal container which has the hot water bath, which is why I'm doing it this way. And then finally, I'm going to put in my anodizing solution here, which is just going to be 3% trisodium phosphate. This is another, it's generally used as a cleaning product, pretty non-toxic. You can use other things, pretty much anything. People use baking soda for this. Pretty much anything that is going to conduct a little bit of electricity should work. But this is recommended by a number of people, so I figured I'd just go ahead and get some. I don't know. We're going to etch in like 2% TSP today. That'll be fine. Oh no, let's friggin' make some up. Why not? Let's make some up. We'll make some more up. We can make it up. TSP. All right. Trisodium phosphate. I'm going to switch over to laptop. Trisodium phosphate. We're going to put in around 30 grams ish. That's fine. And then we're going to pour in around a liter of this stuff. My friend is borrowing my stir plate, so I don't have it. I'll just let it do. So while that heats and while this dissolves, I'm going to show you some code that I wrote for actually running stuff. Live captions win. Is that something that you can actually do on YouTube? Because that would be awesome. Okay. Dissolving. All right, so let's take a look at some code. This is going to be incredibly boring to some of you. Too bad. That actually runs the thing. So actually here, this is the rainbow tester fluid interface. And so you can see it's typical fluid interface. The configuration file is really simple. I can just swap out different config files for different uses of the the tester box, the rainbow tester. So this config file is going to work for the anodizer. I have another one for like the hot end tester, and hopefully I'll have other fun sort of like test things that I can hook up with a DB25 cable. So all we're doing is we've got the stepper X and Z. The Y stepper is sort of phantom, doesn't actually exist. I've got the sweet LEDs, which I need to hook back up. And basically that's it. All it is just controlling a couple axes. It doesn't do anything fancy. And I just sort of calibrated the X axis, which is the variac steps per millimeter, based on the voltage readout that I got. I don't know if that's going to drift over time, but we'll see. So the other thing that I wrote up is some code for actually sort of previewing the gradients for the anodizing. So I made up this fun little gradient based on photos that I took of the keychains, for my test keychains. So each one of the voltage levels here is a color that I pulled off the photo from the keychains. And that sets up this gradient. And so I'm going to use that to sort of like create previews from my generated G code. So for anyone who's interested in the code, I've got a function for generating the step values based on your start and end voltages, the length of your thing that you're anodizing, and whether you're doing a gradient or sort of stepwise. Then I've got another function for generating this sort of like these periodic steps. So this is what we're going to be running today, which is sort of like generating a 1 volt at a time sort of bands, and then like bigger bands at the 5 volt levels. So we'll have something like a backer that has all the voltage levels at 1 volt increments that we can really kind of like fine tune our color palette. And then finally, a little plotting function. So this is the plot, the G code that I generated here that we're going to run today, and it's going to go through the whole voltage range and have these sort of like wider bands at 5 volt increments. We could do something else. We can, instead of starting at 10 and stopping at 95, we could start at like, say, 50 and go to 90. And we could leave these other things the same. And that's going to generate a sort of like different gradient here. And here you can kind of see more clearly these wide bands here. Instead of stopping every 5 volt increments, we could stop at every 10 volt increments. And now you see there's fewer of those wide bands. We could change that ratio to say 7. And now you see we've got these really wide bands at the 10 volt increments. So these would be single voltage stops, and then single increments in between. So I'm going to go take this back 10 to 95, 5, and blah, 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 3. I think that was it. 3 to 1, 5 to 1. Yeah, 3 to 1, I think it's better. And then this is just generating the G code. So the only thing here that you change is really the step time that it's going to hold on each step. And I actually tested this out earlier, and I felt like 2 seconds was not long enough. So I'm going to do 5-second step time here. And I'm going to write that to the file and upload that to our fluid interface. Generating that right now. Very good. Okay, cool. So let's go ahead and take some temperatures, see where we're at. I'm going to go back to this one. So we're at 100 degrees in the etching bath, which is pretty close to where we want it. We'll let that cook for a little bit more. This stuff needs to be stirred by something. This is just basically cleaner in here. I'm not worried about my screwdriver or anything. See what MCU board? It's running SKR 1.4, which is just something I had left over because I put a spider into my V2. Very murdery, yes. It's the shitty one. It's the shitty one. It's dissolved enough. Yeah, I was thinking about the sort of like swapping the angle of the axis would be really cool. I agree. I was thinking about motorizing that, adding like legit y-axis on this. But in case you can't tell, I have a tendency to try and do too many things at once. So I'm gonna try and get this working like right now. 106. Yes. All right. Let's go ahead and do a dry run with no power while we wait for that stuff to heat up. Oh no, I gotta wash the thing too. I'm gonna wash this thing first. Yeah, no, the hanger rotates. So I just need to stick like a rail up here and another lead screw or something. Just because it's not powered, but why not? Okay, I'm gonna go wash this off with some Simple Game. Only thing we're going to murder is the unoxidized surface layer of this titanium. You're welcome. Okay. So I did get a really interesting like burgundy sort of red color um, on the keychains that I just did. So I'm really hoping that we can get that same thing with the backers. It's like a really cool velvety red color. I can actually, still waiting for the shit to heat up. So we can go take a look at the store. So Heartgate got a cool, like a sort of like a bright pinky red, which is cool. And Sindane, whose backers I'm going to actually officially, hopefully, do tonight. After we do the test one, we can confirm colors and stuff. Is going to do like a bright cyan, and then we'll do purple titanium screws for it, which is going to, I think, be really cool. So we're going to go back here. Let's go to the store. Probably shouldn't be showing you my bookmarks. I don't even know how to. There we go. Boom, ba-doom, ba-doom. Hilarious. This is a butterfly keyboard. Not that I can usually type anyway. So here are the keychains, and these are the ones that I just did. And so these are the sort of colors. And I tried taking some different pictures in different lighting conditions, and they're over here in the FAQ. So this is how they look under indirect natural light. This is basically like in front of the window, but like not having light shining directly on it. And this 15 volts gave this like amazing dark red color, which I have never seen before. And I'm wondering if there are like other really cool colors like this that are going to sort of like pop up in the like 1 volt increment somewhere, which I'm very excited. But you can see that under this indirect natural light, a lot of these sort of like fluorescent high voltage colors really pop. Under this is the same light, but looking at it head on, so like exactly sort of 90 degrees down to the surface, and everything looks dark, which is really interesting. But then these are the colors under sort of like warm inside light, just in our kitchen. So it's really cool how different these things look under different light. It's very like I don't have any here because I sent them all out today, but it's a really cool like structural color, similar to like how butterfly wings are iridescent or beetle carapaces. They're very cool. So you can see some of these things close up too. Just this. So this is the sort of like pinker purple high 65 volt color. This is that 15 volt color, which looks a little bit more purple in this picture, and does depend on the angle that you're looking at it. Just cool. They're just cool. I love these colors. I think they're just awesome. That orange is cool too. I like the orange. The 70 purple is like really special somehow. It's somehow like simultaneously purple and blue. And if you get your fingerprints on it, like I have here, it really brings out the purple because it changes the thin film interference somehow. You can wash that off with some IPA, but Just really, I love these colors. They're so cool. Let's try and get some of these colors. Man, I love these things. Okay. Yeah, I'm hoping that the 15 is a match of the Stellar Red because that's what I have on mine here. Um, fingers crossed. Not quite there yet. Not quite there yet. What else do I have to show you? Oh, let me hook the lights up. These are kind of cool. Maybe, does anyone have any questions about anodizing or back ergos or anything that we can like discuss in the remaining 10 minutes or so between now and when we can actually dunk this thing? It's funny that I find myself here. I never would have expected 2 months ago that I'd be sitting here live streaming titanium anodizing. Nothing to do with my background or anything, but it's just super fun. When are we going to take your money? When I'm like ready to actually do the thing. So hopefully very soon. Yours are going to be especially cool, Toby. So Toby's also going to get like a cool gradient. And the other thing we're going to do is splatter some masking. This is the closest thing that I have to nail polish right now. But if you sort of like mask it and splatter with nail polish. Oh, the other cool thing or interesting thing about the titanium anodizing is that since you're growing, the color is determined by the thickness of the oxide layer, and the oxide layer is determined by the voltage, and you grow it depending on the voltage. So like if you if you anodize to 75 and then you put it in a 50 volt bath, nothing happens. Similarly, if you anodize to 50 and then you put it in a 75, everything goes up to 75. So you can do cool stuff with like masking. So if you like splatter nail polish on it and let it dry and then anodize and then use some acetone to get the nail polish off, you can re-anodize at a lower voltage and have this like really neat contrast. So for those ones, we're going to do this like really cool. So similar, like Matt, this is exactly what that's doing. Is you're sort of masking part of it so that it doesn't have any oxide layer. Wash it off, and then you can grow a thinner oxide layer in there to contrast with that thicker one. So, of course, that means like when you go back and re-anodize it, or maybe you anodize to like 1 voltage, a low voltage of the whole thing, and then you mask it, and then you re-anodize. I don't know. I've never done this before. I've just like watched YouTube videos and seen cool stuff online. So I'm really excited to try it. Is the room inspired by the Dexter reboot? It is. It is not. I don't think I've ever watched Dexter, which is a travesty. I really like cartoons. The only variable applied voltage. Yes, so voltage is the only thing that's affecting the growth of the oxide layer. You can also change, there are things about how, so the surface finish of the metal will affect how it ultimately looks. You can see in the keychains, the parts that were etched looked a little bit different from the parts that were brushed. If you mirror polish it, sometimes the colors can look really, really different. If you don't do any polishing at all, it looks very different still. The other thing that really makes a difference is if you etch or not. So if you don't etch and you just leave the sort of natural semi-oxide layer that's on there to begin with, the colors end up coming out very muted, like not kind of more dull, and you don't get those bright sort of high voltage colors. So this etching step is really important to get those high voltage, bright, popping colors. And then it may be the case that the anodizing electrolyte matters to some degree. For instance, I didn't get that cool burgundy 15 volt color when I tried this with sulfuric acid previously. Those are also different alloy, different titanium alloy, so I'm not totally sure. Yeah, just so cool to play with. It's like, it's really not like, there are cool videos online. You can do this with 9 volt batteries and baking soda. So order a order a keychain from Send Cut Send for your dad or your mom or something, and get some baking soda and some simple green and a couple 9-volt batteries, and you can anodize it, and it'll look really freaking cool, especially at those lower voltages, like below 50 volts. You just stack up 9-volt batteries until you get whatever voltage you want, like a 25 or a 30, you get like a nice purple blue or something. Or if you have a titanium pocket knife or something, you can do the same thing. You don't have to use, unlike aluminum, which requires really caustic chemicals to anodize, and then has to be dyed later. It's really straightforward and like pretty safe, all things considered, especially if you're doing a low current power supply like 9-volt batteries. Um, Pretty cool. Multiple layers on top of one another. Yeah, I don't know, like if you're doing like thin film deposition or something. I actually I submitted a quote to get these things with the diamond-like coating, this like hard black shiny stuff. I haven't heard back from that yet, but that'd be really cool. You might be able to, if you plate titanium nitride, it's that sort of like golden color. I don't know if that would anodize further. It's all material science stuff that's like way beyond me. So, but if maybe we can try. I don't know. 114. That's probably good enough. Probably good enough. I'm just going ahead and set this a little bit higher. Anyway, 1, 2, 3, TS. I think that's right. 130. Yeah, all right. I bumped it up a little bit. So this is our test one. It's fine. I think we can do it. Oh, the other thing we're supposed to do is add a little simple green to the anodizing tank. And the reason that we add a little bit of simple green to the anodizing tank is to break the surface tension of the water. I don't know how much is too much. That's probably fine. So when we're pulling it out, it'll just kind of like be even. Let's have Clipper mix this for us. I'm going to go ahead and set up the fancy camera now so you can get a better view of things. All right, Clipper, please mix our tank for us. Put this over here, and let's go. Let's go to z equals 400. How's that looking? $17. Cool. We are getting close. I think that's close enough to call it good. Oh man, I'm getting nervous. All right, so I designed this clampy thing to come out so that I can move the whole um, backer assembly all together. All right, so we're gonna dip this into our etching tank. Um, and it doesn't have to etch for very long. It's really gonna go for like 30 seconds. I think at the lower temperatures is good. A minute. You don't want to leave it in too long or it'll start actually dulling the finish on the material. Kind of mix it up a little bit. Okay, now we'll rinse it off. We don't want our etching solution. Okay, there. Okay, clamped in. Good. Attach our positive electrode. Okay. And attach the negative electrode. Verify that's turned off. It's turned off. And that's just going to attach directly to this stainless steel screen here. And then I'm going to stick it down below the surface. Oh boy. Oh boy. All right. Whew. Okay. Let us do this. So it's a Variac with a stepper attached to it. Yes, it is. Sport mode Crocs. I lost those back things so long ago. Okay, we're gonna do this here. Focus a little bit. All right, and I'm gonna. Cool. Okay. Ba, 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 ba. All right. Turn on the Variac. Boom. Going to home everything. Now I'm going to move the backer down until it is just touching the surface of the water. Um, and that's effectively going to be our 0 point. So that it's starting at basically 0 on the backer. Okay, okay. So with this program, it's going to dunk it all the way down. It'll go all the way down, and then I'll press go, and you should start seeing it like fizz and bubble and stuff. So, going going to go ahead and print. All right. And I'm going to have to leave my thumb on this thing for the whole dang time. It's going to suck. That's okay. All right. So it's currently running about 3 volts under where it thinks it is. So maybe I just need to have like longer hold times for it to get up to voltage. The other thing I'm seeing is that this foam at the top is, oh, amps, thanks. We're at 0.26 amps right now. So not even close to what the Variac is capable of putting out. So right now it thinks it's at 32 volts, but it's actually at 29. So not getting quite the like discrete steps that I was hoping. The foam I think is from the well, it's I think the reason the bubbles are staying there is because of the simple green. Um, Definitely would not use at least this amount of simple green next time. I mean, the gradient is looking pretty freaking sweet. Just we're not getting the like stepwise. Current staying around zero point 0.4 amps. I was thinking about trying to give Clipper the voltage measurement directly. I'm sure I could create a voltage divider and read it in and maybe do a PID process or something. Um, I was hoping to not have to do that. Like hopefully I can just sort of like, well, now we're about 10 volts under. Drawing about 1/2 amp now. Yeah, maybe I'll grab another. I can grab another test one. We can just do another one right away and try the reverse direction. Try doing it at the cap. Yeah, it's way under voltage now. So now it says 74 and it's at 53. Oh, well, that's because my stepper is skipping for some reason. Well, shit. I think actually we just weren't turning it. I think I was skipping steps. Shoot! Well, it's done. Done. We got up to 75. I think that's it. Oh, I also programmed in the wrong height. All right, it's done. Turn that off, turn that off. Disconnect that. I did calibrate the E-steps, however, I didn't calibrate it with the thing going, and also I think I was skipping steps for some reason on my Variac, so. Not super perfect. Alright, I'm gonna get something to wipe that off with. So it didn't get up nearly as far as I wanted to. I think I'm going to do this again. We'll try it going top down. The other thing is cool. So you can see here, I didn't like clean it very well. And this is kind of like a crap piece. So you can really see how important it is to clean it perfectly before you do it in. This is kind of a, let me try getting some IPA here. See if I can't get some of that simple green off. Thinking I went too heavy with the simple green. So you can see, yeah, these low voltages here, there's definitely kind of a burgundy in there. And you can see the steps are a lot more clear right at the beginning too. And they just kind of wash out as we get to the higher voltages. Yeah, I am definitely, so that's one of the things. I've got some titanium screws coming this week, and I've got some nylon nuts that I will be using to put them in, and so you can get color matched, or I can anodize them separately for color contrasting screws. And those will be Torx rather than the typical hex, because the titanium's a little softer than steel, so that'll help it not be quite so. Uh, yeah, I love those oranges in the middle. They're super awesome. So the other thing, I mean, we can also make this a completely smooth gradient uh, just by setting our travel times in our G code. So we just give it a continuous move simultaneously for X and Y rather than moving them in steps, which is what I'm going to do for yours, just so that we get that nice smooth thing. And then I was just hoping to have the steps here so I could say like precisely, this is this voltage specifically, but not on this round. That's why we test things. So okay, well that's not too bad. Not too bad. Not too bad. I'm fairly happy with that. I think that's anyway. I think it's very cool, and we'll try doing another tester. I'm just have to go grab some non-foaming detergent. That's a really good idea. PBW is excellent idea. The mesh cathode is stainless steel, 316 stainless. Um, I don't want to mix up more TSP, so I'm just going to go grab another backer from upstairs. Are they upstairs or are they down here? I swear I had them down here. They're upstairs. Oh no, they're up here. That's right. Stepper amperage, yeah, I could definitely do that right now too. Try cleaning these a little bit. This one hasn't been quite so mistreated as the last one. Maybe we'll give it an extra good clean. Hi, Gadget Angel. I haven't found a place willing to bend titanium yet, but that would indeed be very cool. Okay, so I'm going to chuck this one up into the thing. I'm going to regenerate my G code. So also take a look at these screw heads. Where's the camera? Here. Well, you can't even see that. They're blue now. We're going to put them in the etchant, and it's going to take off that oxide color. So it gives us a chance to like redo things if we need to. This one we're also going to do without the cap installed per Kaios's suggestion. So I just disconnected the cap, and hopefully I'm not changing too many variables at once here. Okay, let that cook, and then let's go back to Safari. And we're going to redo our G code here. So this is not actually 390. I think it's 340. So I'm going to redo that. 340. Let's stop at 100 this time, just because. And I'm going to do our step time of 10 here, just to give us. Oh, and I'm going to reverse equals true. 390 reverse. That's 350, I think. Okay. The thing I'm going to do is increase our stepper current. Oh no. Z is fine. And I'm also going to go ahead and change my step distance. It should actually technically be 150 is what it should be physically. So we'll just set it to that and see what happens. All right. Yes, you can. Gadget, you can DM me and I will send you the secret password or just ask someone in chat to my store where I will be offering this as a service. What was I going to do? A home. Okay. And I'm going to go ahead and wipe this down one more time so that we have it nice and dry for a dip. DC bolts are off. There we go. Okay. Hook up positive lead. I'm going to zero it. So step down. Actually, let me go ahead and I'm going to switch the camera again so we can all see. I'll go ahead and be a little wider this time. Why not? Okay. And going to upload the new G code. Okay. We'll see if this one works. Turning on my power. Doesn't work without the cap. Need the cap. All right, so we need the capacitor. That is interesting. Turns out we need it. That's okay. So I'm going to go ahead and go. 350, we're going to print. I am energizing. I'm not sure why it's doing thought I had it reversed, but it doesn't seem like it's reversed, so I guess we'll just sort of see how this one does. No, it's different G-code, but it was generated in such a way that I think I must have swapped an axis or something. Yeah, software is. They seem to be keeping up a little bit better this time with the voltage. Um, so I think the problem is that I calibrated my steps on the variac without a load on it, and somehow that was reading incorrectly. So I just gave it the values that it should have based on the geometry, and it's working better this time. So we're right at where it says it should be, 28 and 28. We should at least get a better gradient this time, like a more accurate gradient. My thumb is definitely getting tired. So far, we don't seem to be skipping any steps. Good. Right at 34 volts. And it says we should be at 34, 35. So that's good. We are good. Right where we want to be voltage-wise. I think that is just a artifact of the light, Matt. You're not seeing the bubbles just because the LEDs are below, and we're just the camera resolution. The cap is 30 microfarads, millifarads, microfarads. Okay, I'm going to need to get a bigger pulley for this. So we're really dropping off the voltage now versus what it thinks it is, which is super interesting. I don't know if that's due to the variac or due to it not, like maybe the oxide layers not growing fast enough or something. Because it's kind of like slowly creeping up on my voltage meter. Doesn't seem like we're skipping steps at all, but it's just not keeping up. Huh, weird. So we're at 62 volts on the readout now, and we're up to 1 amp, Kaios. So at the higher voltages, we're definitely getting more current, drawing more current. So the other thing that's happening here is making me wonder, if we're running it too long, because it's really looking dull in these higher voltages, in a way that it doesn't when you just do the really rapid anodizing of the keychains. And I wonder if that's just because they're sitting there for so long that it's... Yeah, I think that's at least for the voltage. I think if it's at the voltage, it should be at the correct. Everything should be fine. Like it should have grown the correct oxide layer. So I think if we have Clipper read the voltage directly rather than just guessing it from the position of the variac, that's probably the way to go. A little bit extra work. Well, we're getting a little hot in there. Yeah, I think this like super long anodizing pause is really dulling the metal in the lower bits. So if we're actually doing real backers, I think we'll just do a really smooth gradient. I'm going to call that good. It done. It done. All right. Ooh, it's getting a little toasty in here. Okay, so that's good for the tests. I think before I go to bed, I'm going to do Sindane's backers at a known voltage. Maybe it's just the shit drying on it to make it look. Yeah, it's growing some. It's growing some shmoo. I think it's growing some like not so good shmoo on it. Is it okay if I spray my computer with isopropyl alcohol accidentally? Okay, yeah. I think we're going to need a new etching solution because you can see as we get into the high voltages here, it's not looking nearly as good. Very interesting. Yeah, I think the pulling it out is definitely the wrong way to go. So let's take a look at this here. So up at the top, it's nice and shiny, partly. We've got these really nice colors. Then as we go down, we're developing this like kind of off gray grossness. Not cool. And there's like hints of the really nice specular colors coming through, but it's overall, it's just gotten all gross. So I think what's happening is that the etching that we've done is worn away or something, and we're not getting as good results. So I think I just need to make up some new etching solution and redo it, redo it, redo it. All right. So I think we do need more a new etching solution, a cleaner etching solution and a clean anodizing solution, so that we don't get this sort of like off discoloration here. So I'm going to go ahead and do that for the actual backers. I'm not going to do Syndanes tonight because I need to make up new solutions, but I will post pictures of those on Discord when I make them. I'm sure they'll come out really cool, and also on the website. So thanks for hanging out with me as I played with the Autodizer tonight. Oops. A lot of fun. And I will see you next time. See you around. You bet. Catch you soon. Adios, everybody.